Grounding is art. It's not a standard science. It's more of art. More than 80% of the faults are line to ground faults.
And grounding, is it two different terminologies, do two different concepts?
These two terms are interchangeably used. Not, I would say, not because lack of knowledge, but because moreover the way those are described. Basically, when you say about the grounding, it's that involves the physical Earth. How is it possible to ground something in space? Meaning, how does the International Space Station ground itself?
Hello everyone and welcome to the third episode of the Electrical Guy Power Panel or TPP. In this episode we have Mr. Mandar Kavimandan with us. Now it's certainly a privilege to have him with us today because Mandar is coming with a very rich experience of more than 15 years in power system. He has a bachelor's degree in electrical engineering and also a master's degree from Michigan University, United States. Currently, he is based out of United States and working for a very reputed organization. Now he wears a lot of hats and let me actually read it for you. So Mandar is experienced in different studies like load flow, short circuit, grounding, lightning, relay coordination, lightning risk assessment, voltage stability, system stability. So certainly he is a very knowledgeable person and it's a privilege to have him here. Today in this episode we are going to discuss about the substation grounding with him. And believe me, it's a really interesting discussion. So definitely make sure you watch it till the end to gain all the details about substation grounding. And in case if you wish to connect with Mandar, I'll put his LinkedIn profile down in the description. You can go and connect with him. And in case if you have any doubts in between, feel free to put your doubts in the comment section below. We'll try to answer that as well. Right? So go ahead, get your pen and paper ready and get ready to have a really great learning experience. So, hello everyone, and welcome to the third episode of the Electrical Guy Power Panel. Today with us we have Mr. Mandar, and it's I would say it's a great pleasure for all of us to have Mr. Mandar with us. He's joining us from US, and super happy to have you, Mandar sir, here. Thank you for this opportunity, and thanks to you in advance for sharing all the information that we are going to discuss in today's video. So, thank you for joining us, Mr. Mandar.
Thank you, Gaurav. My heartfelt thanks to you and the viewers here for giving me the opportunity to share what I know.
Yes, certainly. I'm sure it's going to be very interesting for all of us, including myself, because the topic that we are going to discuss with Mr. Mandar today is really interesting and also equally important. Today, we are going to talk about the grounding system in the substations. Well, it is one of the safety aspects of the substation, and when it comes to the safety, I believe there should not be any compromise. And grounding system really helps us in having a safe environment. So it's a really interesting topic to discuss and also equally important. So without wasting much time, let us go and start understanding the grounding. So maybe let's start with the basics first, as usual. So, Mr. Mandar, please let us know what do we mean by this grounding and why it is, very important in substation.
So grounding is basically a system where you connect electrical equipment and or the conductors to the earth. Now we all have heard term called earthing. Earthing and grounding are usually and can be interchangeably be used depending on what country you are in. But to understand the subtle differences between grounding and earthing, so earthing is basically connecting a non-current carrying path, metallic part, to the ground or to the earth. What that helps is whenever there is a short circuit or a fault, we need to make sure that those metallic enclosures, it could be switchgear, it could be generator frame, it could be circuit breaker, transformer, anything. So a person is so the fault current is safely dissipated to the ground. At the same time, the person is not electrocuted. Now, grounding, what happens is the grounding is different. So grounding is moreover connecting a neutral and earth together. So what that does is it basically helps stabilize the voltage profiles along the system. At the same time, it makes sure that any fault condition that occurs in the system, it has a low impedance return path to the source. Now, someone may ask, like, why? What's the difference between neutral? What's the difference between connecting neutral
Yeah.
and the Earth together? So again, technically, that question is very valid. But so consider a probability. When you have the AC voltage, right? We need to so that could be AC or DC voltage. What happens is when the current flows through the circuit, we know that current needs to have a closed loop path.
Mm.
Just the basic electrical circuits. So without the neutral, how the current is going to flow back to the source because it needs a return path, right? So that's what the neutral is for. And but the ground is different. So ground is moreover for the safety. So that's a very high level at the same time subtle differences between earthing, grounding, and why do we connect between neutral and the ground?
Hmm. Okay, so I think very important point you mentioned that now this question is very commonly asked. So if I have the neutral, do I still need to have grounding? And that you clearly mentioned that neutral is to provide the return path, but grounding is to provide the safety. But
Yes,
maybe if we imagine a scenario, Mandar, so let's say we have a substation, but I have not provided grounding. What could be the scenario in this case?
yes. So what happens is, for example, if we have a substation without any grounding system, so chances are, what happens is whenever there's a fault current, typically most of the about 70 to, I would say not 70, but closer to, I mean, I don't know the statistics worldwide, but more than 80% of the faults are line to ground faults,
Yeah,
meaning
true.
that those are asymmetrical fault that involves the ground. It could be, tree branch contacting with the transmission line, or there's short circuit. That could be anything. So what happens is whenever there is a live conductor touching the ground, um, the GPR is called as the ground potential rise. What happens is the current flows to the ground. Now, depending on what type of soil it could be sand, it could be clay, it could be, the concrete, it could be asphalt. Depending on the soil composition, the ground potential rise of that particular area at the fault location, for example, within the substation and its vicinity, it could be 10 feet, 20 feet, 5 feet, it could be really high. Now, what happens is when we have such a higher ground potential rise, without any metallic or without a low impedance path, the effects of those ground potential rise to subside down is entirely dependent on when and how the systems or when and how the protection relays will operate. Now, if there is a delay in operation, then that potential rise or the fault will feed the ground, and then that potential rise will be sustained.
Mhm.
And then what happens is if someone gets in contact with it, those person might experience the electric shock. A simple example could be, when we have the horses or the cattle or, cows, basically, what happens is when they come in contact with these GPR, the their steps, their legs are, at two different potentials. So basically, we are having a short circuit there, and
Ah.
that could be same for the person. If a person is basically approaching a substation fence, now they may or may not have the shoes on them, and those shoes may or may not be safety shoes. So
Mm.
essentially, if a person is approaching the metallic portion or any metallic enclosure within substation and immediate outside of its vicinity, and they touch it accidentally or knowingly, chances are they might experience a shock, and that's why this is very important topic, or this why
Mm.
the grounding is very critical for not only the safety of the personnel but the overall power grid.
I think very valid point because in case if grounding system is not there, so might be there could be loss of life as well if some person is in the vicinity of that faulty substation.
Yes.
So I think it's very important topic when it comes to the safety, when it comes to the grounding. So thank you for that basic understanding on grounding, Mandar. Thanks for that. Okay, so in the first question, you mentioned a subtle difference between grounding and earthing. Okay, so maybe, and this is a very commonly asked question, even in the technical interviews. A lot of people have this question in their mind. So, Can you please focus more or maybe throw some more light on this earthing and grounding? Is it two different terminologies, do two different concepts, or is it the same concept? Can you please share more details on this?
Yes, thank you, Goro. And that's a very interesting question because a lot of times these two terms are interchangeably used. Um, Not, I would say, not because lack of knowledge, but because moreover the way those are described. So earthing in a simple manner is, connecting any non-metallic current carrying part to the ground, as simple as that. So that could be the frame of our electric iron, the frame of our electric motor, the frame of the water heater. Simple. Wherever there is a three-phase neutral supply, or that could be single phase as well, depending on what type of equipment it is.
Mm.
And earthing, sorry, and the grounding is moreover the connection or to provide a reference point, right? Because we need a reference. Because unless we have a voltage difference or uh, uh, the current cannot flow,
Correct.
we need to have a difference. Yeah. So we need a reference point, and that reference point is the grounding for the whole system. So I
Mhm.
hope it is clear. Earthing means, in simple words, connecting your non-current carrying uh, metallic portion to the ground, or that could be frame of the motor, frame of the electric iron, frame of the equipment in general.
Mhm.
And grounding is moreover connection between the neutral and the ground. That could be earth. So
Okay.
that's why the term earthing and grounding can and may be used interchangeably.
Mhm. And that's perfectly fine. I mean, if you say earthing or if you say grounding, it's not a crime. It's
Yeah,
a
it's not real. Yeah,
okay,
yeah,
okay. That's good to know because a lot of time, these terms are interchangeably used and there is a lot of confusion. Okay, is it, earthing is right, grounding is right, but I think the answer that you gave will clear a lot of confusion among the people. Thank you. Thanks for that answer, Mandar. Well, now, certainly based on this discussion, it sparked an interest into me, and now I want to know what are some of the key objective of this grounding system in a substation, and also there is a concept called Earth grid, I believe, or ground grid. So, what is the objective of this whole system?
yeah. So the objective of the grounding system is to, of course, safety is the forefront of it. I mean, that's the underlining one. Then the other one is about making sure that our system or the whole power grid in general has a reference point to for the voltage stabilization. At the same time, provide a low impedance. I would say impedance because inherently there is inductance in the power grid because that's not a purely resistive circuit.
Correct.
So the impedance part to the grid. So those are the three objectives. And apart from that, so safety that comes under, for safety, safety of the equipment, safety of the personnel, safety of our, um, I would say, utilities that are coming in and going out of the substation.
Mm-hmm.
Now, the way now you mentioned about electric, basically earth grid. So depending on the type of the substation, the type of the fault current, uh, the area, geographic area of the station, soil parameters, what kind of soil it is, you may or may not require a grid. Grid meaning it could be a simple mesh of conductors, horizontal and vertical, arranged in a certain pattern. Now, if you look at some of the guides like IEEE or IEC or even IS, which is the Indian standards, they have their own requirement based on, again, their grid profile, their geography, and also the kind of fault currents available. Now, these grid arrangements, it could be, vertical and horizontal conductors spaced at a certain distance. It could be a tight mesh. Tight mesh means the distance between the horizontal and vertical. It could be narrow, I mean, very small. It could be sparse grid. And a lot of it is will dictate on your design parameters. So that's
Mm-hmm.
the very um, high level difference of like high level um, brief of about why it is important and basically what are the objectives of the grounding and and what does the earth grid means.
Correct, correct. So Very clear, Mandar. So I think the top priority goes to the safety, as we discussed. Even we discussed what could happen if there is no grounding system provided. And since you mentioned about also the earth grid, so this earth grid or the mesh that we are talking about, you will generally find it on top of the substation or under the ground. How is it? Maybe just brief on that.
Yes. So since this is earthing, or I would say grounding, for that reason, and earth is involved, the physical earth is involved, it will be below the earth, meaning below the compacted soil. So what happens is whenever there is a substation to be built, the top layer is slightly removed, is called as a, and then the non-native fill. So what we do is like when we have the native soil, it's just like gardening, for example. When you have to plant a tree, right? You basically dug a pit, put the tree in it, and then just compact the soil around it. Same thing with the grounding, as simple as that.
Yeah.
Basically, prepare the site. Now, depending on the site, for example, if the site is a landfill, then you may have to take out some of the material and then put some non-native fill, just like what we have for the different type of trees, right?
Hmm.
Same thing. So usually the ground grid is buried about 1.5 to 2 feet below the compacted soil. Now, some people, I mean, personally, whenever I do the design or whenever I review any of the designs or studies, what I prefer is I prefer to be very clear that whether it is bottom of the crust rock or top of the crust rock, the ground grid depth. But usually, in the guides like IEEE, 80, it is mentioned about 1.5 to 2 feet below the grade. Now that grade could be final grade and final grade also. Like I mentioned, it could have that crushed rock, which is I would say the crushed stone. Some people call it as a crushed stone or crushed rock, interchangeably like earthing and grounding. Based on its thickness, it could be above or below it. But personally, I like to be very clear about it and call it like below the bottom of crushed rock, 1.5 feet or 2 feet below the bottom of crust rock.
Okay, okay. So, I mean, of course, since it is underneath the earth, it will not be visible to human eye. So
Yes, that
only
is
if you
right.
have done the design or okay, there is earth grid inside the earth, then only you will know. Otherwise, it's difficult to understand just by looking at the substation.
That is right.
Okay, okay, Mandar. Thanks for that insight. It was really helpful. Now, we talked about the objective. We talked about what is grounding. Now, can you share us maybe what are the different methods that we used for grounding in the substation?
Absolutely. So I would say, when I was working on the grounding, when I started first, someone told me, one of my mentors, grounding is art. It's not a standard science. It's more of art. And the reason because a lot of these currents, when they dissipate in the ground, those are electromagnetic currents. And
Mm.
based on the kind of a structure that we have within, like below the ground, those mutual interaction and because the current is AC, there are some mutual inductances. So again, based on that, you may or may not have to have. I mean, the conventional design is of just a square grid, as we discussed the first time.
Mhm.
But apart from that, different combinations could be a combination of earth grid, horizontal vertical conductors with the ground rods, uh, or ground wells. So ground well is basically same as or water well, where you dug the water well maybe a few feet deep. Now again, there are a lot of variations based on the soil, its composition. It could be certain feet. Then you basically insert a conductor and connect it connect it with the ground grid. Same thing like a fishing rod. You have a bait. You
Mhm.
basically have a conductor. You just put it in the water. Same thing. Just assume that bait is a conductor, your string is the connection to the grid, and your fishing rod is the ground grid. As simple as that.
Mhm.
So based on that, you could have a combination of grid plus rod plus ground wells, or ground wells and grid, vice versa.
Mhm. Okay. So when you say ground well, so like it's very deep, or we have some standard, length or for something like that. Do we have?
Yes, so typically ground wells, those are really costly because what happens is those have to be dug deeper, just like
Mhm.
our regular water well.
Ah.
Again, um, um, caution, or I would say just a note here, based on the soil composition. Now, don't take my word for it, because most of the designs I have seen is about 100 feet. Some designs that we have done on some of the projects that I reviewed was about 150 feet deep, and then we hit a basically gas layer below it. So that depends on what kind of a geology is it, but usually those are quite deeper, about 100
Mm.
feet roughly.
Okay, okay. And just out of curiosity, so you said we'll dig a well and we'll give the ground there. So can we use that water? Because
No,
if
you cannot, because
yeah,
yeah, exactly. So what
so
happens is when you dug the ground well, you basically pour one of the chemical called as GEM, ground enhancement material. That's a
Mhm.
combination of there are manufacturers like Erico and some of the companies who manufacture that specific compound that can retain the moisture. But then the issue is we do not want to have our whole well filled with the water. So.
Correct. So I think important if you have a well near the substation, make sure you are not using water out of that because it may also have currents. In case if fault current is happening, ground fault is happening, maybe the water is conductive. So
So, so I would say the reason we don't want our well to be filled with the water is
Mhm.
because we don't know what kind of a salt it is in the
Mm,
salt composition in the water, and based on that, it may or may not corrode our electrode. So,
mm,
like, like I said, basically grounding is an art. So sometimes the soil is good. That if it's a regular clay, we may not have corrosion, but if the grounding system is the near the I would say tropical area, like for example Mumbai, right? So
mm,
and then in some of those some of those semi-urban or the urban areas where the substation or the facility is right next to the shore, uh, we may have some of the alkaline content that may or may not corrode it. So not only we need to pay attention to the type of conductor we choose, but also need to take into account the soil corrosivity.
correct, correct. Absolutely rightly mentioned that, Mandar. So you mentioned three, four different systems. So what I'll do is maybe just to summarize, uh, I'll take all the non-conductive parts in the substation. So if it's an outdoor substation, so the support structure of all the equipment like circuit breaker, disconnector, instrument transformer, and everything, even the marshalling boxes that we have in the substation, I'll connect it to one grid. Maybe it could be a mesh underneath the earth, or maybe it could be a well, and I'll give all the connection. I'll put it there, right?
Mhm. Yes. So
Okay.
typically what happens is you basically have for example, let's take a simple building or building within the substation fence or power transformer or the power circuit breaker. So what happens is typically guides recommend that you connect the opposite legs of those frames to the nearest grounding point. That could be, like you said, that could be grid, that could be ground rod, that could be ground well. So
Hmm.
as simple as that.
Okay, okay, very, very clear, Mandar. And I really like that statement when you said grounding is an art. So, no doubt about that. So, thank you for sharing that. So, if you're finding this video helpful and if you're learning from it, then kindly consider liking this video and also subscribing to the channel so that you will be notified for next video update from our channel. And if you have any questions, put it in the comment section below. We'll try to answer that as well. Thank you. So we discussed about the different most commonly used grounding method. Now I want to know, since we have different substations. Okay, we have high voltage substation, we have medium voltage substation, then we also have low voltage substation at different voltage levels. So the methods that we mentioned a few minutes ago, do they apply to all this different voltage level, all this substation, or it changes based on the voltage level? So high voltage I may have different, medium voltage different, low voltage different. What's the scenario here?
Definitely, that's interesting question. And like we are discussing, right? It's an art. So what happens is based on the different voltage levels, the fault current varies, and also the protection and the relaying. So meaning our bulk system, for example, above 100 kV, just making a very I would say, generalized statement, because those are the bulk assets, and then we need to make sure that all of those, all of that particular power circuit is maintaining a stability just for the whole power grid, because otherwise we will have the blackouts. So what happens is, based on that, we have the largest substation because larger the voltage. And again, I'm presuming we are talking mostly about the AIS, not the GIS. GIS is in the building. So
Hmm.
again, so predominantly we are just concentrate on the AIS. With the higher voltage, we need to have the highest physical spacing between the conductors because air is an insulator.
Correct.
So its footprint is much more larger than the medium voltage or the low voltage. Same applies with the current. So
Hmm.
based on that, based on the current, I would say based on the fault current study, those could be different for high voltage, medium voltage, and low voltages. Now, in a very simple manner, the more critical the substation is, like the high voltage stuff, you will need to have a more robust, redundant, at the same time, uh, kind of a grounding system which will ensure that uh, the probability of fault and it's clear and getting cleared is close to 100%. I would say 99.99. But then again, since the fault inherent is um, uh, is probabilistic in nature, we can say that we need to have more robust system for the high voltage. For medium voltage, it may or may not be depending on the fault current.
Hmm.
And for the low voltage, let's say for low voltage, just take a simple example of a distribution transformer, which can be pad mounted, supplying a typical residential or the industrial load. Again, we don't have any ground grid, and some of those transformers, like the source of the primary source, the primary side of the transformer may be connected to a neighboring substation, which is 5 to 10 kilometers, or 2 to 3 miles away. At the same time, the secondary side is supplying the load. So for that particular transformer, which is kind of a low voltage, it could have just a simple pad mount, a simple ground ring around its periphery with four ground rods.
Hmm.
Now, again, but that is based on what kind of a sizing of the what size of the transformer is. So to answer your question, yes, they do vary based on high voltage, medium voltage, low voltage. We're just trying to provide more context of for our
Yeah.
audience who may encounter these situations.
Exactly, exactly. And it's very important. So, uh, can we say this statement like the more is the normal system voltage, the more complex or more redundant the grounding system we need?
Yes, we can say we need to have a more robust system for our high
Exactly.
voltage substations. Yeah.
Okay, okay. I think that's important to know that like if people are coming in from different substation experience, low voltage, medium voltage, high voltage, I think this answer will really help them to understand. But while answering, you also touched upon a point, okay, AIS and GIS, air insulated and gas insulated. Maybe briefly, can you please tell us like the grounding system for air insulated and the grounding system for gas insulated? Do you see a major difference in the grounding system in both these types of switchgear, or is it more or less same?
No, definitely there is a difference, and based on the application, it could vary a lot. So two examples. First, like I said, for the AIS is pretty simple. I would not say simple, but more of a generic understanding of how the ground grid is, because there is no building in it. I mean, we do have the control house for the relay and the panels, but again, that control house, those control house metallic portions are connected to the ground. What happens is GIS usually within the building that is enclosed. And based on that, that could have a multi-layer, meaning first layer within the ground, first layer at the ground floor, second could be, second floor could be elevated for the breakers, and third may be transformers, and vice versa. It could have a basement, first layer at the ground, and the top layer. So based on that, what happens is each of those floors will have its embedded concrete rebar to hold the structure. At the same time, that rebar can be used as a grounding, because that is a very dense connection to make sure that the concrete and the whole structure is like hold in place. And then most of the manufacturers like Hitachi, Siemens, Mitsubishi, basically whoever are the GIS manufacturers, and that could be that could be any particular manufacturer. They perform those studies, make sure that their GIS system and the building is ensuring to make sure that those that grounding and the fault currents are safely dissipated
Mm-hmm.
between the enclosure and the ground grid. And at the same time, they do make recommendation of when, where, and how to connect their enclosures. For example, if you have a GIS breaker, the manufacturer will specify in their reports or in their technical specification how and where those breakers will be connected, whether that will have a certain type of sizing of the conductor that needs to be connected to the rebar and then rebar to the ground grid, which is outside.
Mm-hmm.
But yes, to answer your question, yes, GIS, AIS differ. Also, the grounding for the solar, renewables, battery energy storage, it differs because those kind of facilities, they don't have um, the mass, meaning they don't have the rotating mass. So they
Mm-hmm.
basically disconnect instantly. So
Yeah, I think now since you talked about this, I believe it's a very vast topic, the grounding, because it
it
is
is, it
varying
is.
even voltage level to voltage level, the type of switchgear that we are using, and now I've started to agreeing to the statement that you mentioned. Grounding is an art.
Yes, it is.
So yes, thanks for that answer, Mandar. So my next question to you, Mandar, is so we have a lot of switchgear in the substation, okay, and everything is governed by some sort of standards. So there could be IEC standard, Indian standards, or IEEE, ANSI, and different kinds of standard. Even what clearance we should be maintaining between the two phases, between the two equipment, there is a guidance for that. So, do we have some sort of standard even for grounding? Anything, any standard, any government body is having some obligations on standards?
That's a very valid question. Yeah, like you mentioned, Gaurav, based on the country, based on the geographic area, based on the system, the standard could vary. Now, yes, we do have standards. I personally would like to call it a guide because it's more of guidelines and the applications vary. So one is IEEE 80, 80. The latest version is IEEE 80-2013, which is the latest version of it. Same thing, IEEE 81, 2012, which is associated with the grounding. That's for the North American, I would say pretty much largely followed around the world. We have IEC 603, 64 or 46, one of that for the Europe. We have the Indian standard 30 IS 3043 for the grounding. And apart from that, so these are the guides, I would say, for the grounding system pertaining to their own geographic area, pertaining to their own systems. And again, but these can be used interchangeably because, like we said, there are only so many conductors and the configuration that these can be used interchangeably.
Okay, okay. So certainly there are standards, there are codes available for the grounding system also, like the other switch gears.
Yes.
Yes. Okay. Okay. Thank you for that information, Mandar. So since we are talking about the grounding, so there are two concepts which will always come when we, discuss about the grounding system: the step potential and the touch potential. So maybe can you help us in understanding these two concepts?
Yes. So step potential is basically if a person is approaching any of the substation which has the ground potential rise, the distance between a generic, like for IEEE 80, they do categorize the step and touch potential and the equations for two persons or like two individuals with weight of 50 kg and 70 kg. 50 kg is more conservative because of the body resistance and stuff. But at the same time, those are the two um, body weights used by the IEEE. Now, step potential is basically the difference between your two feet, which are 1 meter apart, roughly 3.14 feet apart. Same thing with the touch potential. So when you are basically when your hand is touching any of the metallic, I would say exposed metallic component within the substation, that could be one substation fence and
Mhm.
your feet. So that's the difference. So touch potential is different between the area you touch and your feet, and step potential is the difference between your 2 feet, which is roughly 1 meter apart.
Okay, okay. So maybe let's say if I'm walking in a substation where there is a ground fault, and
Mhm.
so the distance between two my distance between the feet is basically the step potential.
Yes, so it's basically 2 feet between that is 1 meter apart. And touch
What?
potential is if this is your substation and you're touching this here, so this point and your feet is the touch potential.
Touch potential. So if, for example, I'm touching the support structure of a circuit breaker and my feet is there, so the difference between these two is basically the touch potential.
Touch potential. Yes, sir.
Okay,
That's
okay.
right.
I think very clear. And how these concepts are important in the grounding.
So what happens is consider, consider the heart, meaning our heart is very sensitive to because within our human body is also, I mean, that is governed by the electrical system.
Yeah, yeah,
Grounding system needs to ensure that the fibrillation current for 50 or 70 kg weight of a person is below the threshold,
yeah.
meaning that's the current beyond which the person may not survive for the shock, depending on how much rating is, because there is a let go current, meaning when you touch something and you have a sensation, you can still let go about those, because there is a point where you can let go. But then what happens is as the current approaches to that fibrillation level, you may not have the ability to let go the current or let go the conductor because your muscles gets contracted at the same
Mhm.
time. um, that may not be simply possible. So that's why step and touch potentials are important to make sure that a person is safe.
Okay, great. I think that was really good to know the difference between the step potential and the touch potential, and also the importance of it that you mentioned. So thank you for that answer. Now we're talking about substation grounding. So whatever switchgear that comes into the substation, those switchgear are tested for their performance. So when I say, okay, my switchgear is tested for this particular IEC, the customer can say, okay, this is a robust product tested for its performance, and I can fully trust on this. But same thing for grounding. Do we have something like this? Do we test the grounding system to check its performance? Is it working fine or is it not working fine? How do we monitor that?
Definitely, that's a very valid question because you cannot test something which you cannot see, because grounding is the first thing that goes
Yeah.
in the ground. And typically what happens is it's no one concerns until someone gets kind of a sensation at the fence or some other equipment. That's when all the concerned stakeholders are kind of realize that we need to have something. But yes, definitely there are some recommendations or standard, or I would say procedures to test the integrity of the grounding system. IEEE 81 2012 Section 10 is the one which provides these methods. Now, like I said, based on the application, based on your availability, based on the testing equipment, this can be interchangeably be used. But there's a method called as a fall off potential. Now,
Mhm.
again, I'm just trying to help trying to help our audience understand that fall off potential is one of the most respected in the industry because it gives you the correct correlation between your design grade or like between your design and the actual physical installation. Now, it again something designing in the software or the simulation world may or may not replicate it exactly, but the results are very close. I would say, depending on the design, the soil, and how it is tested, um, I would say 10 to 15% variation is generally observed. It may be less as well for a robust or for a well-designed system. But I'm saying that fall-off potential method is the one to basically come up or to test your overall grounding impedance of the ground grid. That includes combination, like I said, mesh, ground rods, ground wells, basically interconnected. Second is ground grid integrity testing, meaning uh, and how you can visualize this is, you just take a multimeter, place it between the resistor, and when you hear that beep sound, you make sure you
Yeah.
basically know that the circuit is intact. So that is called as a ground grid integrity. Now, like I said, in IEEE, there are different methods specified in section 10. That could be a DC test. It could be a high frequency. So basically, any frequency that you can use, um, which will not interfere with the power frequency, which is 60 hertz, 50 hertz, depending on what region you are in the world.
Mhm. So these are the two method that is used to check the performance of the grounding system, or the grounding system is in a good condition or not.
Yes, so fallout potential, integrity testing, and that has a different, type of test, meaning clamp on meter test, and also the soil resistivity. That is one
Yeah.
of the tests which is a basis of the grounding design. But since that is a design parameter, again, that is equally important, but it's a first step that goes in the grounding design.
hmm Okay, clear. But these tests that you mentioned, they are performed before commissioning the substation, or is it recommended that yes, one, you have to perform all these tests before the commissioning, and also in between to check the performance, check the suitability of the grounding system.
So for the greenfield, meaning when the substation is brand new, I would
Mm.
say usually these tests are performed. The fall of potential is performed before the substation energization. For the brownfield, which are substation already in place, these can be performed. Again, fall of potential and integrity. But then, like I said, uh, those are basically performed after the installation of the ground grid, not before.
Okay.
Soil resistivity, though, can be performed before and after,
Mhm.
because sometimes when you have the non-native fill, you may have to check the you may have to make sure that your design system is within those variations of the compacted soil. So non-native fill. So yes.
Okay, okay. I think very clear, Mandar. So this is something I didn't knew, to be very honest. So interesting to know the different test and when it should be performed. So thank you for your answer. So my next question to you, Mandar, is so we are looking at a modern substation today. Okay, if we compare it with the previous 10-year and the substation that we have today, of course, a newly built substation, we notice a significant amount of difference, not in the way they are arranged, but the digital system, the AI is getting involved into the substation. We have switchgear monitoring system which can predict the life of switchgear, which can predict when the next fault may occur. So those are the advancement we are looking into the switchgear and into the substation also. So do we have anything for grounding system also? Is there any digitalization happening, any modern technology or something that is coming into near future? Do you see any of such thing happening with the grounding?
Yeah, that's a very interesting question. And with like you said, with the modern substation automation, a lot of research, I would say there is a revived interest in the grounding and the electromagnetics. Now, because the sheer nature of the grounding is, it is below grade, you can only see so much based on, because you cannot physically see it. But the technologies like non-destructive testing or the integrated testing are being, revived and, modified as well to make sure that we assess the overall health of the system. For non-destructive testing is used in nuclear reactors, to check for any of the I would say the fractures within the reactor itself. Also, it is used in the pipelines.
Mhm.
Same thing with the and so basically apart from that, that could be a smart sensors like you said, to basically check and monitor the ground grid integrity or its health. Now these techniques, so there are some products available, but again, um, predominantly the best and the simple is to make sure that your first step of the grounding design is very robust. At the same time, you follow all the industry specifications, all the standards, and then with some of these newly developed techniques, you can implement some of the sensors, smart sense. I would say real time. I would say real-time mapping as well, because some of the techniques like ground penetrating radars and stuff, they are available, but because they're expensive and at the same time, you have to manually map it. Now radar can give you some kind of um, again, like I'm saying, based on the geography, the results may vary drastically, or it may not. So, ground penetrating radars, smart sensors, mapping, geology, these are some of the techniques that are being developed. At the same time, there are some manufacturers who have been uh, rolling out their products. Now, how much they are in the market being used by the utilities, is subject to interpretation, or that's something which for which the data is not really available.
Mm-hmm. Okay, I think clear. But have you experienced any project maybe where you have used such kind of advanced technology? Any experience you have with that?
We have some of our clients where they have used the ground penetrating radars, because what happens, like you said, some of these substations are being close to 60, 70 years old, because
Mm.
that's when most of the power system was built,
Yeah.
or basically that kind of infrastructure. Now what happens is some of the ground grids may have corroded over that, between that period. So ground penetrating radar is one of the techniques which I have seen being employed by different utilities to some extent, where they may not have the data available. Now, when I say the data available, meaning they may not have the drawings, or the drawings could be really old, like say, 50, 40 years old, and then they might have added some more system to their substation, meaning they could have added the power transformer, they could have expanded their fence, they could have added more ground grid. Now, because they cannot check what was installed before, they can just connect the new grid to the nearest location and then assume that everything is okay. But apart from the ground penetrating radars, ground grid integrity testing is something I have seen commonly employed to test some of the integrity of the legacy system. Legacy means the old systems.
Yeah, the old systems. Okay, I think it's really interesting, the advanced technologies that are coming, and maybe in future, since it's absolutely right that most of the power system, was built 50, 60 years ago, and we might even see some solutions that can help us in retrofit activities. So may not be, we have to replace everything, but there can be some solutions which can be fitted in the existing system itself.
Now, since you brought up that topic, let me just share for our viewers. There is something called the modular ground grid designs. Now, just like our 3D printing, right? What we print, and there's a concept called as a mobile substation, which is just for which the whole substation is basically
Yeah.
on the trailer, and you
Yeah.
can just move it around. So there are some of the modular design for the ground grid where you have these arrangements prefabricated, but again, those applications are very sparse. Or I would say the commercial deployment of that, I don't know. I don't really have any insights or data where I can just share it. But I'm just saying that, just as a knowledge from knowledge perspective, there
Mm.
are some of these methodologies, like you said, basically grid advancement that are coming into play.
Yeah, yeah. Really interesting to know that, and thanks for all the insights, Mandar. Really appreciate that. So maybe I'll ask one last question because I couldn't hold myself asking this. So if let's say there is a new person, I'm new to the grounding system basically. So if I have to start learning about grounding, because this discussion what I had with you really sparked that interest into me and to go ahead and learn more about the grounding. So if there is a new person like me, very new to the grounding, how should I start or where should I start learning about grounding? Maybe briefly, if you can share with me and also with our viewers here.
Sure. I would say, the best way to learn about the grounding and its philosophy is IEEE guide. It is very well documented. A lot of researchers, lot of engineers, and lot of industry engineers and industry researchers and the professors from around the world have contributed immensely, I would say. Um, and so that's a very, very good starting point. It has all the concepts what you need. At the same time, so two guides, IEEE 80, IEEE 81. Also, I would, for the people who are geographically located in their basically different continents, they can use their own, own standards. But most of these standards, for the continents are basically derived from IEEE. So IEEE 80 and 81 is the starting point. Apart from that, there's again, by no means this is a promotion, but there are softwares like ETAP, CDEX, and WinIGS. They have, I mean, they have their own website and the knowledge base. So let me just share an example. For example, there's a company called Safe Engineering Technologies in Canada. They have developed software called CDEX, Current Distribution Electromagnetic Grounding Simulation. CDEX is the short form, CDEGS. If you go to their website, www.scstech.com, and if you just search in their search bar knowledge base, they have some of the common questions, where how to do the grounding design. Again, those may not be from a step by step, but then they do have material where they show you basically, you just fill out a form, you can download their engineering resources. So apart from IEEE, anyone can go to some of these commercially available softwares, websites, and they have tutorial videos, maybe their engineering guides to learn about it. And again, let me just share, grounding is not only just substation. There's AC interference phenomenon when you have a solar facility and solar facility fence and the neighboring transmission line going parallel to it. Utilities like Bonneville Power Administration, Power Grid Corporation of India, also different utilities like basically Hydro-Quebec in Canada, they have immensely, like I said, immensely contributed to these guides, and there's a wealth of knowledge available for anyone who would be interested to learn about grounding.
Sure, sure, definitely. And I think after this call, I'm heading to all those websites that you mentioned to learn more about the grounding system. So thank you, Mandar. Thank you so much for this really insightful discussion. Now, I always say this statement, there are a lot of experts available in the industry, no doubt about that. But getting their time is a really challenge. But I would say it's a fortune. I was very lucky that I got your time. You shared this insight with all of us. I really thank you for this help, and I really appreciate that. So thank you so much for your time again.
No, Guru, again, like I said, thank you for the opportunity to share what I know about the grounding with our viewers here, and it was a pleasure be with you, and great to know you. And again, if uh, for the people who are watching this one, if they have any questions, feel free to reach out to Goro, and then we can definitely collaborate. But one more thing that I want to share is, when I was working on my projects, grounding, just something interesting for our viewers.
Yeah, sure.
So basically, when you say about the grounding, it's that involves the physical earth. How is it possible to ground something in space? Meaning, how does the International Space Station ground itself?
Interesting.
That's a question that was a question interesting to me. So when I looked at it, NASA had figured out there's a report called so they utilize something called as a uh, proton controller, this is a plasma controller unit. So
Mhm.
it basically is a collection of basically that's called as a PCU, and that collects all the static electricity, and it uses some kind of expellent called as a xenon gas to release the plasma in the low Earth orbit. But that's something interesting to know and learn if you guys really want to learn about it. For anyone who is curious, like watching this particular episode, they can just Google search it. The report is available. It's a collaboration between NASA and the MIT. So definitely check it out. It's worth reading it.
Yeah, definitely. Interesting point that you mentioned. Grounding in space. So, okay, when you
Yes,
have ground, you can do it, but how do you do it in space? A really interesting topic.
exactly.
Certainly, I think I will also go and check it out. But as Mandar mentioned, if you have any sort of questions, you can definitely put that in the comment section below and we'll try to answer that. And you can also connect with Mandar. We'll put his LinkedIn profile in the description. If you wish to connect, know more about the grounding, definitely Mandar is there to help all of us. So thank you so much for watching, guys. We'll see you in the next episode. But till then, keep watching, keep learning.